In this video, we shall look at a problem that outlines the difference between static friction and kinetic friction. A 2 kg box is initially at rest on a horizontal surface, as shown here. At t equals to 0 seconds, a horizontal force given by this expression, with t measured in seconds, is applied to the box. We note here that there is friction that acts between the surface of the box and the surface of that horizontal floor. Thus, the acceleration of the box as a function of time is given by this following expression. It is 0 for time in between 0 seconds to 3 seconds, and its acceleration is time dependent as shown here for time greater than 3 seconds. We want to determine the coefficient of static friction between the box and the surface, and also the coefficient of kinetic friction between the box and the surface. We will note that at t equals to 0, although the force begins to act, due to the presence of friction between the two surfaces, that 2 kg box will remain stationary up until t equals to 3 seconds. Only after that it will begin to move with some acceleration. So let's look at the free body diagram of this 2 kg box. So the first thing that you should label is the horizontal force, F, which is a function of t given by that expression. Of course, you have weight, which is given by 2 times gravity because the mass of the box is 2 kg. As a result of that, there will be a normal force acting upward, opposite to that of weight, which in magnitude is the same as the weight, namely 2 times gravitational acceleration. And one final force is the frictional force that acts opposite to that force. Let's label that as F sub mu. Now this friction, F sub mu, could be static friction or it could be kinetic friction, depending on whether the box is moving or not. As a result of all these forces, one could also generally label acceleration like that. We again note that this capital F and acceleration are functions of time. We know that the acceleration is 0 up to t equals to 3 seconds. And as soon as t becomes greater than that 3 seconds, this object will start to accelerate according to that expression. So what that means is at t equals to 3 seconds, the frictional force, in this case, it is the static friction, is maximum. Because static friction is given by an inequality as follows. This is the coefficient of static friction, this is the normal force. The maximum value of static friction is given by that expression, which is mu sub s times n. So for part A, we want to determine that mu sub s, which is the coefficient of static friction. Because at t equals to 3 seconds the object is not moving, then the forward force, the magnitude of capital F, must be balanced by the maximum value of the static friction given by that expression. So you can simply write mu sub s times the normal force. And this happens at t equals to 3 seconds, so we need to evaluate the magnitude of that force F at t equals to 3 seconds, and that is just 2.5 times 3. And that must be the same as mu sub s times normal. Normal force is 2 times gravity. So you see from this equality we can solve mu sub s, and mu sub s is just 2.5 times 3 over 2 times gravity, and that's going to be about 0.38, and that's the answer for part A. Note, coefficient of static friction has no units. Now let's look at part B. We need to determine the coefficient of kinetic friction. Kinetic friction, given by F sub k here, is equivalent to the coefficient of kinetic friction times the normal force. So kinetic friction is actually given by an equality instead of an inequality like we saw for static friction. We also note here that kinetic friction acts on a body when the body is in motion. So in this case, that happens for t greater than 3 seconds. So at t exactly equals to 3 seconds, the motion will start to take place. And as a result, the friction that would start to act on this body is the kinetic friction and no longer static friction. So in this free body diagram, for part B, the friction is the kinetic friction. And let's analyze Newton's equation of motion. The forward force is F at t equals to 3 seconds. The backward force is the kinetic friction. So the net force is F at 3 seconds minus kinetic friction, and that equals to mass times acceleration at t equals to 3 seconds. We note here that although we are writing acceleration at t equals to 3 seconds, and over here it is given to be 0, up to a good approximation we are referring this result as acceleration at time just after 3 seconds. So let's substitute the numbers. F at t equals to 3 is 2.5 times 3 from that expression, minus kinetic friction, which is given by that expression. Mu sub k is what we want to determine. Normal force is 2 times gravity. Remember, the value of gravity is 9.81 meter per second squared. And that equals mass. Mass is 2 kg. And acceleration at t equals to 3 seconds can be determined from that expression to a good approximation as 1.3 times 3 minus 2.6. If you feel uneasy of placing t equals to 3 here, you can place any number that is very close to 3. For example, 3.000000001, for example, because technically the motion starts after t equals to 3 seconds. And even when you substitute a number such as this one, you will see the result that you get for mu sub k is very, very close to what you would get by substituting t equals to 3 seconds there. So solving this equation for mu sub k, you would get mu sub k equals to about 0.25. And that is the coefficient of kinetic friction between the box and the surface. And that solves the problem. Thank you for watching.